Welcome back to our next lesson in complex numbers. What we're going to look at today is a relatively easy topic. It's called solving linear equations involving complex numbers. Now, you've solved many linear equations before. Remember, what you do to solve a linear equation is you find your variable, which is usually x, and there's going to be x in these two examples we look at as well. You have to get the x by itself on one side of your equation. And then whatever is left on the other side of your equation, that is the answer. That should be the solution to your equation. These are a little different because these involve j's as well, or imaginary units. So we have to take that into account when we're solving them. Let's have a look at the very first equation here. We have 4 multiplied by j to the power of 8 multiplied by x. So there's your variable. There's your variable. That's what you have to solve for. Plus 5j to the power of 4, and remember that's just a number. You're not solving for j, remember. You know what j is. J is the square root of -1, that imaginary unit, and then it's equal to 13. So what we should do here is, first of all, as you were doing with regular linear equations, take everything that doesn't have an x to one side of your equation, and everything that does have an x, you leave it on the other side of your equation. So you're going to call this 4j to the power of 8 times x. You could even simplify here if you wanted to, is equal to, and on the other side of your equation, you're going to have 13 minus 5j to the power of 4. Now, let's simplify those powers of j, shall we? Using the rules that we saw in our last video. J to the power of 8, well, let me think. 8 is a multiple of 4. So this is just going to turn into a 1 multiplied by x is equal to, and on the other side of your equation, you're going to have 13 subtract 5 multiplied by j to the power of 4. Well, 4 is obviously a multiple of 4. So j to the power of 4, that's going to turn into a 1 as well. So really what your equation becomes, 4 times 1 times x is 4x, is equal to, on the right-hand side, you're going to have 13 subtract 5 times 1 is 5. So you have 4 times x is equal to 13 minus 5 is 8. Divide both sides by 4. And the solution to this equation appears to be x is equal to 2. And if you wanted to, you could plug that back into the original equation to verify, and that should be your solution. Okay, next equation. Let's have a look at that. And I'll just draw a line down here. Notice that this one has the square root of a negative number already in it. So let's write that in terms of j. Remember what we were doing previously, we could break that apart into the square root of -1 multiplied by the square root of positive 16, and so that's just 4 multiplied by j. So we're going to change that into a 4j. So we have x times 4j plus, now, 3 times j to the power of 3. Let's simplify that now, shall we? J to the power of 3, remember, is -j. That's one of the ones that you should remember. Equals, and then on the right-hand side we have 7. J to the 13. 13 is not a multiple of 4, but 12 is. So if I break that apart into j to the 12 multiplied by j, and the j to the 12, of course, remember, that's just going to become a 1. And then the last term we have is plus 4. J to the 7, I'm going to break that apart into j to the 4 and j to the 3. And then we have an x there as well. Now notice this time you have 2 x's in this equation. You're going to have to get those together on one side. So we're going to have x times 4j, which is 4jx plus, whoops, sorry, not plus, it's going to become a minus, isn't it? That's going to become a minus 3j equals, and on the right side, j to the power of 12, that's 1. So you're just left with 7j, and then plus 4, j to the 4 becomes a 1, that's gone, j to the 3 is negative j multiplied by x. So there are two terms with x's in them. Let's get those together. So 4jx. When I bring this to the other side, the plus 4 times negative j times x, that also becomes plus 4jx. And you're going to have on the right-hand side 7j plus 3j. The sign changes, remember, when you bring it over. So this becomes 8jx is equal to 7j plus 3j. You can add those together because they're like terms. You get 10j. Divide both sides by the 8j. Remember, your goal is to get the x by itself. They cancel there. And so what you're going to end up with is x is equal to 10j over 8j. The j's cancel. 10 divided by 8 reduces to 5 over 4. So that should be the solution to this second equation. So remember, the goal is when you're solving linear equations involving complex numbers, yes, you may have to simplify the powers of j as well. You may have to write the square roots of negative number in terms of j, but the goal is the same as any linear equation you've solved previously. Get the x's together, get the regular numbers together, and you solve for your x in that fashion. Okay, so now you'll notice that on the bottom of that page, page 4, there are some other examples there that you can try. Please do these on your own time, and check your answers with the solutions in D2L. If you're having any trouble with any of these, if you're not understanding what you're doing, please pop me off an email or send me a message somehow, and I'll certainly get back to you. Okay, so that's it for this video. I'll see you in the next video. Bye-bye.